Hi everyone, welcome back to my YouTube channel, Chemistry with Sumitpramar. In this video, we are going to solve past paper questions from the unit Chemical Periodicity. Let's look at question number 1, which says, the labels had become detached from 4 bottles in the laboratory. A student realized that the contents of one of them could easily be identified because in the addition of water, it would not give the fumes of hydrogen chloride, which did not give the HCl fumes. Let's look at the options. Option A is aluminium chloride, which has a covalent character. So it will react with water to give HCl fumes. Hence this cannot be an answer. Second option is SiCl4, which is a covalent molecule. Hence it will react with water to give HCl fumes. This cannot be an answer. Similarly, PCl5, option C, is also a covalent molecule, and this will also react with water to give HCl fumes. So this cannot be an answer. Option D is magnesium chloride, which has ionic character, and it is an ionic compound, and it dissolves in water. It does not give the HCl fumes. Hence D is the correct option. Question number 2. What is the correct order of the decreasing melting points of the 4 chlorides shown? HCl, MgCl2, CCl4 and S2Cl2. As we know that among all of these, magnesium chloride has ionic character. This is an ionic compound. Hence, MgCl2 will have the highest melting point. HCl, CCl4 and S2Cl2 are simple covalent molecule. Hence, option C should be the correct option. Question number 3. Consecutive elements X, Y and Z are in the third period of the periodic table. Element Y has the highest first ionization energy and the lowest melting point of these three elements. What could be the identities of X, Y and Z? Let's look at the trend of first ionization energy. If I plot a rough diagram for the first ionization energy, we know that the first ionization energy increases from sodium to magnesium, and then it decreases for aluminium, and it again increases for silicon, and then for phosphorus it decreases for sulfur, and then chlorine and argon. This is sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. Similarly, if I plot the rough diagram for melting point, we know that melting point increases from sodium to magnesium and then from magnesium to aluminium, and the highest melting point is for silicon. So this is for sodium, magnesium, aluminium, silicon, and phosphorus has very low melting point. Sulfur has slightly higher melting point, and then chlorine and argon. This is phosphorus, sulfur, chlorine and argon. Let's look at the options. Option A is silicon, phosphorus and sulfur. This is silicon, phosphorus and sulfur in the first ionization energy trend, and we can see that P, phosphorus, all of these three. And if I look at the trend for melting point, I can see that phosphorus has the lowest melting point. Hence option A should be the correct option. The period 4 elements gallium, germanium, arsenic and selenium are elements directly below aluminium, silicon, phosphorus and sulfur in the periodic table. So these are period 3 elements. Period 3, aluminium, silicon, phosphorus and sulfur. And period 4 elements which are just below are gallium, germanium, arsenic and selenium. The question is, the properties of each of these period 4 elements resemble the properties of those of period 3 elements. Which period 4 element forms an oxide that dissolves in water to give an acidic solution? So we can compare the properties with respect to the period 3 elements. We know that aluminium oxide does not dissolve in water. Similarly, silicon dioxide does not dissolve in water. That means gallium and germanium will also have similar properties and they won't dissolve in water. So these cannot be an answer. phosphorus oxides. We know that P4O10, it reacts with water to give H3PO4, H3PO4, which is uh, acid. Similarly, sulfur oxide like SO2 reacts with water to give H2SO3, which is acidic in nature. That means these oxides, phosphorus and sulfur oxides, dissolve in water to form acidic solution. Hence, arsenic and selenium will also form oxide, which dissolves in water to form acidic solution. Hence, option C should be the correct option. Question number 5. Which graph correctly shows the relative melting points of period 3 elements plotted against their relative electronegativities? And the elements that have been taken are magnesium, aluminium, silicon, and phosphorus. And we know that among all of these elements, silicon has the highest melting point, right? It has a giant covalent structure. So if I consider this, we know that A cannot be an answer, because in the y-axis, along the y-axis, silicon should be at the top and aluminium is at the top, so this cannot be an answer. Similarly, D cannot be an answer. Here also aluminium is at the top. Either option B or option C can be the correct option. So let's look at the next trend, which is electronegativity. And we know that electronegativity increases across the period from left to right. That means phosphorus should have the highest electronegativity. That means along x-axis, this one should be at the rightmost side. That means this one, option C, is the correct response. Okay, let's look at the next question. A table of 4 substances and their physical properties is shown. Which substance have the correct properties? Okay, so first one is silicon dioxide. It is insoluble in water. It is a poor conductor. It is poor conductor in solid and in molten state. That is correct. And it is a covalent, giant covalent structure. So it has very high melting and boiling point. So it is correct. This one is correct. NaCl, sodium chloride, is soluble in water, and it is incorrect. So that means this one is not correct. Aluminium is good conductor, good. Okay, let's look at the melting and boiling point. Melting and boiling point of aluminium is high, but these are low. That means this is incorrect. SO3, when you dissolve in water, it forms H2SO4, which is an acid, and it can dissociate into ions. Hence, it is a good conductor in aqueous solution. But if I talk about SO3 in molten state, it is poor conductor. It does not have any free electrons. Electrical conductivity in solid state is also it is a poor conductor because it does not have free electrons. Since SO3 is a simple molecular structure, so melting and boiling point is also very low. Hence, this one is correct. So the correct option should be C, silicon dioxide and sulfur trioxide. Okay, let's look at the next question. Non-metallic elements and their atoms can have the two following properties. Property 1 has no paired 3p electrons. Property 2 has an oxide that can form a strong acid in water. Which properties do phosphorus and sulfur have? Okay, let's look at sulfur. Sulfur atomic number is 16. We write down the electronic configuration. It is 1s2, 2s2, 2p6, 3s2, 3p4. Let's make the orbital diagram of 3p subshell. Since there are 4 electrons, so 1, 2, 3 and then 4. So we can see that one of the orbitals is paired. Hence property 1 is not true for sulfur, right? Let's look at the second property. It has an oxide. So sulfur forms an oxide, sulfur trioxide SO3, which reacts with water to form H2SO4, and this is a strong acid. Hence property 2 is true, right? Property 2 is true for sulfur. And let's look at phosphorus. Phosphorus atomic number is 15. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p3. Let's make the orbital diagram. 1, 2, 3. Okay, so there are 3 electrons, 1 electron in each orbital, and they're unpaired. So yes, property 1 is true for phosphorus. Property 1 is true for phosphorus. Let's look for the property 2. Phosphorus forms oxide P4O10, which reacts with water to form H3PO4, and in balance state 6 and 4. This is called phosphoric acid, and this is a weak acid. Hence property 2 is not true for phosphorus. So for phosphorus, property 1 is true, and for sulfur, property 2 is true. Hence D is the correct. Elements X and Y react together to form compound Z. Element X and Y are both in period 3. Okay, element X has the second smallest atomic radius in period 3. Okay, let's look at the trend of atomic radius. As we know that atomic radius decreases across the period from left to right. That means sodium has the biggest atomic radius, then magnesium, and aluminium, silicon, phosphorus, sulfur, chlorine, and then argon. Because the nuclear charge increases, hence the atomic radius decreases. So second smallest atomic radius, that means chlorine. This is our element X. Okay, let's look at the next part of the question, which says apart from argon, that means except argon, there is only one element in period 3 which has a lower melting point than element Y. If I look at the trend in melting point, we know that melting point increases from sodium to magnesium, then from aluminium increases from magnesium to aluminium, and from aluminium to silicon. Silicon has the highest melting point, and then from silicon the melting point decreases for phosphorus, and for phosphorus and sulfur has slightly higher melting point because it is S8 molecule, and phosphorus is P4, and sulfur will have more number of electrons, so van der Waals forces are stronger, so it has slightly higher melting point than sulfur, and then melting point decreases for chlorine, and then finally for argon. So chlorine and then argon. So it is saying that except argon, so we're not counting argon, and it's saying that there is only one element which has a lower melting point than Y. We can see that phosphorus, below phosphorus there is only one element, that is chlorine, which has a lower melting point. Hence Y is phosphorus. So the compound Z is formed by the reaction of phosphorus and chlorine. So the correct option is D, PCl3. Which properties do compounds of silicon and aluminium have in common? Option A is their oxides are amphoteric. Aluminium oxide is amphoteric, but silicon oxide is not. So this is not true for both. And B is their oxides are insoluble in water. SiO2, silicon dioxide, is insoluble in water. Aluminium oxide, Al2O3, is also insoluble in water. So this is common for both. So hence option B is the correct option. Period 3 elements can react with chlorine to produce the following chlorides. Period 3 elements also react with oxygen to produce oxides. When the oxides are produced is when the period 3 elements is in its highest possible oxidation state. That means all of these elements are in its highest oxidation state in its oxides. So we have to find out which element have higher oxidation number in its oxide, right? So magnesium chloride, magnesium will react with oxygen to form magnesium oxide, where it has an oxidation state of +2. Here also the oxidation state is +2, so they are same. If I look at the aluminium oxide, it is Al2O3. Oxidation state of aluminium is +3. Here also it is +3, so they are same. For silicon oxide, SiO2, the oxidation state of silicon is +4 here. Here also it is +4, so they are same. PCl3, phosphorus forms P4O10, and the oxidation state of phosphorus is +5 here, and here it is +3. So we can see that there is a higher oxidation state in its oxide for phosphorus. Phosphorus is one of the elements. Sulfur forms SO2 and SO3. oxidation state in SO2 is +4 and in SO3 it is +6. So in both of them you can see that here the sulfur oxidation state is +2, which is increasing when it is forming sulfur oxide and sulfur trioxide. Hence phosphorus and sulfur should be the correct option, option D. Thank you for watching my video. Please like, share and subscribe to my channel Chemistry with Sumit Pramar.